Welcome to the deep dive. Today we're tackling a really central challenge in the world of large language models. How do we actually get them to align with what we, as humans, want?
Right. And a big piece of that puzzle involves reward models. You can think of them as these sort of AI analysts trying to predict human preferences, but, at scale.
Exactly. They're the engine behind things like RLHF, reinforcement learning from human feedback. They provide that crucial signal, that feedback, guiding the LLM towards better responses. More helpful, less harmful.
Absolutely. But building ones that are really effective, that's proven pretty tricky.
Yeah, the current methods often, well, they fall a bit short. You got scalar reward models, they just spit out a single score. It's a black box, basically. You don't know why it preferred one response over another.
Then there are the generative ones. They give you text explanations, which sounds better, but sometimes that reasoning feels a little thin, maybe superficial.
Right, like it's not getting to the core of the issue.
And that's the tension, isn't it? We want transparency, we want the model to show its work, its reasoning, but we also need it to grasp the uh, often subtle, complex nature of human preference that's deeper than just surface features.
Precisely. And that gap is exactly what the research we're diving into today is trying to tackle.
This is where it gets really interesting from an academic standpoint.
Okay, let's unpack this. Our focus today is on a really novel approach detailed in the paper RM-R1, Reward Modeling as Reasoning, plus its supplementary materials. It's work coming out of University of Illinois Urbana-Champaign, UC San Diego, Texas A&M, and Stevens Institute of Technology.
Yeah, and what they're proposing is honestly a fundamental rethink. Instead of just predicting a preference score or label,
Uh-huh.
the core idea is to make reward modeling itself an explicit reasoning process. That's a major departure.
A major departure. Okay, so our mission today is to really get under the hood of these reasoning reward models, or ReasRMs, especially the RM-R1 family they developed. I want to focus on the innovations, the academic insights, the things that genuinely advance the field here.
Agreed. Not just what they did, but why it's innovative.
So we've touched on the limits of current RMs. Let's get into the core of this new idea. Reward modeling as reasoning.
Okay, so the central hypothesis, the big idea, is that the reward model should actually perform interpretable reasoning first, before it even makes a judgment.
So it has to think it through step by step.
Exactly. It's directly inspired by the success we've seen with chain of thought prompting, or COTI. We know models often do better on complex tasks when they articulate their reasoning process.
Right. Compare that to the old scalar RM, just a score, totally opaque. Or even standard generative RMs, where the reasoning might be, like you said, a bit weak or missing the point.
Yeah, the paper actually has a figure one, if you could see it, that illustrates this really well. It shows a standard model versus the reasoning model evaluating a potentially harmful response.
And the standard one might get sidetracked.
It might focus on, say, politeness or the format, like if it's a nice list, superficial stuff.
But the reasoning model, the Reason RM,
It's designed to look deeper, to consider potential emotional harm, lack of necessary warnings, the actual substance that makes a response problematic.
this is really the crux of the innovation then. They're not just tweaking things, they're proposing a whole new class, reasoning reward models, ReasRMs.
Yes, they are a type of generative model, meaning they output text. But the key difference is that the task itself is explicitly framed as reasoning. It's not just generating any text explanation, it's generating a structured rationale.
And RM-R1 is their implementation of this idea.
That's right. RM-R1 is the family of ReasRMs they developed. They've released 6 models spanning 7 billion to 32 billion parameters.
And crucially, they've made the code and the training data available on GitHub. That's huge for the community.
Oh, definitely. Openness is key for verification and building upon this kind of work. But the real innovation, I think, lies in how they train these models. That two-stage pipeline is quite novel.
Okay, let's get into that. The two-stage training. Stage one, distillation of high-quality reasoning chains. What's the goal here?
Well, the main goal is to bootstrap the model's reasoning ability, specifically for this task of evaluating LLM outputs. You're essentially giving it good examples of how to think through a preference judgment.
Like teaching it the ropes of evaluation reasoning.
Precisely. And they do this using what they call oracle models. Think top-tier models like Claude 3.7 Sonnet and OpenAI o3.
Okay, the heavy hitters.
Yeah. They use these oracles to generate detailed, structured reasoning traces for a subset of preference data. They actually used Claude first, then had OpenAI o3 review and correct, aiming for really high accuracy in those reasoning steps.
Interesting. So a sort of cross-checking process even at the oracle stage.
It seems so. This process creates their distillation dataset, Mascalala. It's a collection of these expertly reasoned examples.
Got it. And the RM-R1 model learns from this.
Exactly. It's trained on this data set using a standard negative log likelihood loss, basically learning to predict those reasoning steps provided by the oracles.
So you're teaching it to think out loud like the experts. Makes sense. That's stage one. What about stage two?
Stage 2 brings in reinforcement learning, specifically RL with verifiable rewards, or RLVR.
Okay, why RL after the distillation?
Good question. The idea is to further sharpen that reward-based reasoning and, importantly, improve generalization. Distillation is great, but models can sometimes just memorize the patterns in the distillation data they can overfit. RL pushes it to apply the reasoning more broadly.
I see. And which RL algorithm did they choose?
They went with Group Relative Policy Optimization, or GRPO. One neat technical point is that GRPO doesn't require a separate value function, which can simplify the RL setup a bit.
Okay, and how does the learning actually happen in this RL phase? What's the reward signal?
This is where another key innovation comes in, their chain of rubrics, or TLR rollout strategy. It's how the model structures its evaluation during RL training.
Chain of rubrics. Sounds intriguing. How does it work?
First, the model has to classify the input query. Is it a reasoning task, like math or code, or is it more of a chat task?
Ah, because you'd evaluate those differently.
Exactly. For reasoning tasks, the model is prompted to actually try and solve the problem itself first. Then it compares the provided responses to its own solution to judge correctness.
Okay, makes sense for things with right-wrong answers. What about chat?
For chat, where it's more subjective, the model has to generate its own evaluation rubrics, the specific criteria it thinks are important for that particular chat response.
Wow, okay, so it defined its own standards on the fly.
Yes, and crucially, it has to justify why it chose those rubrics. Then it evaluates the responses based on the rubrics it just created and justified. The paper's figures, 3 and 4, show the kind of structured prompts they use for this.
That's quite sophisticated. It's learning not just what's good, but how to decide what's good in context. What about the actual reward value?
Interestingly, they kept the reward function quite simple. Basically, +1 if its preference prediction matches the ground truth label, and -1 if it doesn't.
Really? That's simple.
Yeah, they mentioned trying more complex rewards, like for formatting or style, but found this simple correctness-based reward worked best, probably because the base models are already pretty good at format and style. The core challenge is the preference judgment itself.
Okay, so that's the innovative two-stage process. Distillation for foundational reasoning, then RL with this chain of rubrics approach for refinement and generalization. How did these RM-R1 models actually stack up in tests?
Right, the empirical results. They tested them on standard benchmarks, reward bench, RM bench, and RMB. Each tests slightly different things.
Can you briefly recap what those cover?
Sure, reward bench is pretty broad chat, reasoning, safety. RM bench digs into more subtle distinctions, especially in technical areas like math and code. And RMB focuses on helpfulness and harmlessness in more realistic, kind of real-world interaction scenarios.
Okay, and the performance.
The results were, frankly, very strong. RM-R1 models hit state-of-the-art or near state-of-the-art across the board.
Outperforming others.
Yes, often outperforming much larger open models like Llama 3.1, 405B, and even proprietary giants like GPT-4o in several evaluations. The gains on RM bench were particularly impressive, up to 12.8% improvement in some cases.
12.8%. That's a significant jump in this field.
It really is. It strongly validates their reasoning-focused training approach. For instance, their 14 billion parameter RM-R1 model based on Q-Instruct beat the DeepSeek GRM27B model, which is almost twice the size.
So the training method seems to be a huge factor, maybe even more than just raw parameter count here.
That's definitely a key takeaway. How you train the reward model matters immensely.
Did the models generalize well, or were they specialized?
The models based on Qian-Instruct showed really solid performance across the different domains, chat, safety, reasoning. They were good generalists.
Okay.
The ones based on DeepSeek Distilled, which already had more reasoning pre-training, really shone on the reasoning-heavy tasks in RM Bench, Fath, and Code. They actually set new state-of-the-art scores there.
So some specialization benefits depending on the base model.
Exactly. And interestingly, the Instruct-based models were quite data efficient, achieving good reasoning performance without needing as much specialized training data.
Let's talk about another innovative finding. Scaling effects. What happens when you make these ReasRMs bigger or give them more thinking time?
This was another really positive result. They found near linear performance gains both when increasing model size and when allowing for longer reasoning chains at inference time.
So bigger models and more computation both help significantly.
Yes, and consistently. Figure 5 in the paper shows this quite clearly. Crucially, the larger models benefited more from the reasoning-based training. It suggests a strong scaling law is at play here.
That's a key difference from some older scalar RMs where scaling didn't always yield big improvements.
Precisely. It suggests this reasoning framework is highly scalable and likely to become even more important as base models get larger and more capable.
They also did ablation studies, right? Testing the importance of each part of their training recipe. What did those show?
Yeah, those were insightful. They compared a few setups, just using RL from a cold start with simple rules, then cold start RL but adding query categorization, reasoning versus chat, and finally their full RM-R1 pipeline with distillation, RL, and query categorization.
And the results?
Clear progression. RL alone wasn't enough for top performance. Adding query categorization helped, especially for reasoning tasks, but the full pipeline, including the distillation stage, was crucial for hitting SOTA performance across the board, especially on hard tasks and safety.
So that initial distillation step is really foundational.
Absolutely. The innovation lies in that synergy between distillation teaching the how and RL refining the what.
They also compared this whole reasoning approach against just doing supervised fine-tuning, SFT, on the final answers, didn't they?
Yes, a fundamental comparison. They looked at SFT alone, SFT after distillation, just distillation, and the full distillation plus RL pipeline.
What was the main finding there?
The consistent result was that any method involving reasoning, even just the distillation stage alone, beat the SFT-only approaches, even with less data sometimes.
That really highlights the core value of making reasoning explicit in the reward model itself.
It strongly suggests it's a more effective way to capture and transfer nuanced human preferences compared to just showing the model the final correct answer.
Okay, to make this concrete, let's talk about that sickle cell disease case study from the paper. It really illustrates the difference in evaluation.
Right, it's a great example. The query asks for symptoms of sickle cell disease. They show two chatbot responses. Chatbot A gives a numbered list, but it contains inaccuracies. Chatbot B gives a more comprehensive text focusing on accuracy and context.
And how did the different types of reward models judge them?
The cold start RL model, the one without the sophisticated reasoning training, actually preferred Chatbot A.
Even though it had errors. Why?
It focused on superficial things. It liked the numbered list format, thought it seemed comprehensive because it listed many items. It completely missed the factual errors.
Oh, wow. Prioritizing format over medical accuracy. Not good.
Not good at all. Now contrast that with RM-R1.
How did it evaluate them?
RM-R1 generated its own rubric first, explicitly stating that accuracy of medical information was the top priority for this query.
Okay, context aware.
Exactly. Then it analyzed both responses against that rubric, identified the inaccuracies in Chatbot A, and therefore strongly preferred Chatbot B for its factual correctness.
That's a night and day difference. You can see the reasoning, you can see why it made the choice, and the choice is clearly better.
Precisely. It highlights the interpretability win. The judgment is transparent, based on clearly articulated, relevant criteria. That's a huge step up from an opaque score or superficial reasoning.
Okay, so wrapping up, let's quickly summarize the key innovations of RM-R1 again.
Sure. First, the core idea, framing reward modeling as reasoning. Second, the innovative two-stage training, distillation plus RL using that chain of rubrics strategy. Third, the clear demonstration of positive scaling effects. And fourth, the significantly improved interpretability through explicit reasoning and rubric generation.
And these innovations led to state-of-the-art performance, beating bigger models in many cases.
Correct. And the researchers aren't stopping there. They pointed towards future work like automatically inducing rubrics, using active learning for preference data, and extending this to multimodal models and agents.
So this approach has legs. It seems likely to influence future work significantly.
I think so. It represents a real advancement in how we tackle AI alignment, making it more principled, more transparent.
This has been a fascinating deep dive. It really feels like a move towards more robust and understandable AI alignment.
It definitely leaves you with a provocative thought, doesn't it? How might this shift, this focus on reasoning within the reward model itself, fundamentally change how we build and trust complex AI systems going forward? Something to chew on.
Absolutely. And if you want to dig deeper yourself, remember, the code and data are out there. Thanks for joining us on the deep dive.
See you next time.